Using the law of cosines. Now we already looked at the proof of the law of cosines, but now we can actually use it to help solve our triangles. For example, if we have side angle side and we know a side and an angle and then the angle in between them and then the other side, like say for example we know C, A, and B, we can't use the law of sines to solve for that because in order to do that we need to know a side opposite of one of the angles. And in this case, we don't, having side angle side. Or what if we know all of the side lengths and we don't have an angle to compare? We can't use the law of sines for that either, and that's where the law of cosines comes in handy. Now the law of cosines says that if we take a side and we square it, it's equal to the sum of the other two sides squared, so a squared plus b squared in this case, minus 2 times those same side lengths times the cosine of the angle across from the side we're looking for. So if we're looking for C, it's the cosine of angle C. So we could rewrite this in lots of different ways depending on what side lengths are given, and that's just for this triangle right here. It could be a different triangle with different labels, but we could rewrite it as a squared, so we're looking at this side length, equals b squared plus c squared, the squares of the other sides and then the sum, minus 2 times b times c times cosine of a. So it's that angle opposite the side length. Or we could rewrite it as b squared equals a squared plus c squared minus 2ac cosine of b, that angle across from my side length. So I want to use the law of cosines when I know a side angle side or a side side side, and it's very helpful to solve that triangle. So for example, we want to find C if A is 15, so our side length of A is 15, and B is 18, and the measure of angle C in between there is 34 degrees. So in this case, we're going to be solving for C, and we know the angle, the measure of the angle across from it, it's 34 degrees. So we're going to use this one right here, where we have C squared is equal to A squared, which is 15 squared, plus 18 squared, minus 2 times 15 times 18, that's A and B, cosine 34 degrees. That's the angle across from my C. So I can do cosine of 34 degrees on my calculator, multiply it by these two, multiply it by a 2, and then I can square this and add the 18 squared and subtract all of this calculation, and if I do that, I get C squared is equal to 101.32. Taking the square root, and of course I only want the positive square root because I'm talking about a side length, I get C is equal to 10.07. Now let's take a look at this if we want to solve the whole triangle. So let's see how we can use the law of cosines. So here I have a triangle. I have again ABC triangle, and I want to solve. I know the measure of angle A is 47 degrees, C is 27, and B is 22. So I have my side angle side here, and I know I can't use the law of sines right away because I know my measure of this angle A, but I don't know this side length. So I don't have a sine A over A where I know all of those values. So I'm going to go ahead and use the law of cosines. Now I want to find, let's find A first in this case. So I have A squared, and I don't have to. I could have found the angle measures as well, but I'm going to go ahead and find the side length. A squared is equal to B squared plus C squared minus 2BC times the cosine across from the one we're looking for, cosine of A. Just substituting values in there, 22 for B, this is my B, 27 for C, this is my C, minus 2 times 22 times 27, cosine of 47 degrees. This is just a value. So just doing all of this multiplication and squaring and then subtracting this, I get A squared is equal to 402.8. So taking the square root, I get A is approximately equal to 20.07. So now I know A. I know this side length. Now I can use the law of sines because I have an angle and a side length across from that angle. So I have sine of 47 degrees over my A, which I now know is 20.07, is equal to the sine of b over 22. And I just chose b. I could have chosen c as well and then done c, sine of c over 27. I just chose b. And then going ahead and multiplying both sides by 22 to isolate my sine b. So 22 times the sine of 47 over 20.07 equals sine b. I just isolated this. Now I can't just divide by sine. I have to take the inverse sine of both sides. So the inverse sine, I went ahead and solved for this. This right here is just a number. It gives me about 0.8. So 0.8 is equal to sine b. And then taking the inverse sine of both sides, I'm going to get b by itself. So that's my measure of angle b. Inverse sine of 0.8. You just put that in on your calculator. So the inverse sine, the sign with a little -1, of 0.8, and I get the measure approximately 53 degrees. So now I've solved for this. I know this side length is 20.07. And now I need to make sure I've solved all my side lengths, which I was given 2, so I'm okay there, and all my angles. So I have my measure given to me here, and I just solved my measure for angle B. Now to solve my measure for the last one, my angle C, I can just add these two and subtract them from 180. So 180 minus 100, 47 plus 53 is 100, gives me 80 degrees, and that's the measure of my angle C. All right, let's look at one more example, and we're not using A, B, and C here, just to see if you can take that and you can use a different triangle. So here I have QRP, and looking at this, I see I have my side lengths, but I don't have any angles. So I can't use the law of sines, which requires me to know at least one angle and the side opposite from that. So I'm going to use the law of sines the law of cosines to solve for this. So the side across from capital P, this is little p, this would be little q, and this would be little r. And so I know that p squared equals q squared plus r squared, the other two sides, and they're both squared, added together, minus 2 times q times r times the cosine of p, opposite angle of the side length. And then just substituting values in there. I have a 29 I substituted in for p, a 31 I substituted in for little q, and a 48 I substituted in for my little r, minus 2 times that QR cosine of P. And that's what I'm trying to solve for. So, and I could have used any of these to start out. I just chose P randomly. You could have chosen R and rewritten this in terms of R squared. I just chose P. And so then doing all of this calculation, so I'm squaring 29, I'm subtracting this stuff from 29, and then I'm dividing by this. So if you can imagine, you're going to be taking 29 squared, you're subtracting 31 squared, and you're also subtracting 48 squared. So you're going to get this nice negative number, but you're going to divide by -2 times this stuff right here. And so you're going to end up with a positive number, 0.815, and that's equal to your cosine of P. You're trying to isolate this cosine of P. Then to undo this, you're going to take the inverse cosine of both sides. When you do that over here, you just get your P, your measure of angle P. And here, arc cosine of 0.815. You just put in your calculator and do the arc cosine. And the angle measure is going to be 35.5 approximately. That's approximately equal to P. So now we know what our angle measure of P is. We know this. This is 35.5. And we know the side across. So now we can use the law of cosines. So I know that P is 35.5, so I can take the sine of 35.5 over the side length that's opposite 29, and that's equal to the sine of Q over 31. Okay, so I'm going to try and solve for my Q here. And I could have done the same thing with R if I wanted to do that. Instead, I just chose Q. And then what I did here is I multiplied across, so I have 31 times sine of 35.5 is equal to 29 times the sine of Q. And then I'm just isolating sine of Q by dividing both sides by 29, And I get this lovely thing right here. And I can go ahead and type that into my calculator and come up with a value. So I can do sine of 35.5 and then multiply that whole thing by 31 and divide by 29. And I get 0.62 is equal to the sine of q. I want to undo that sign, so I take the inverse sine of both sides. So inverse sine of 0.62 is equal to my angle measure of q. Taking that inverse sine on my calculator, I get a 38.3. That's an approximate measure of my angle Q. And now I have my angle P and I have my angle Q. I'm just missing my angle R because I was given those 3 side lengths. And so I can just add Q and P together and then do 180 subtract that. And when I do that, I solve for my measure of angle R. So 180 minus those 2 added together, and it's 106.2.